This is the kind of AI that doesn't just analyze data, it creates. From hyper realistic faces to stunning artworks and even synthetic voices. GANs are redefining what's real and what's possible. But how do they work? And why are two neural networks competing the secret behind this breakthrough? What is a GAN? What if AI could dream? GANs are like two AIs playing a creative game, and the results are stunning. GAN stands for Generative Adversarial Network. It is a type of AI model that generates new data like images, music, or text that looks exactly like it came from the real world without any artificial features. It does this using two main paths: the generator, which creates fake data, like a new image, the discriminator, which tries to detect whether that data is real or fake. They play a game. The generator keeps trying to fool the discriminator, and the discriminator keeps getting better at spotting fakes. Over time, the generator becomes incredibly good at making realistic outputs. How do GANs work? Let's break it down. Two neural networks. The one goal is realism. The first step is the generator creates an image from random noise. As a second step, the discriminator looks at that image and compares it to real images. As a third step, the discriminator gives feedback. Is it fake or real? As a final step, the generator learns from that feedback and tries again. This loop continues, improving both sides like a fogger and a detective sharpening each other's skills. We have already seen the power of GANs even if you didn't realize it. Let's explore some real world applications where generative adversarial networks are making a big impact. In deepfake videos, GANs are behind the creation of deepfake videos, which are highly realistic fake videos where someone appears to say or do things they never actually did. This technology has raised both creative and ethical questions. AI generated art tools like DAL AE and ArtBreeder use GAN like models to create unique and stunning artwork from simple prompts or image combinations. Artists and designers are using these tools to spark creativity and generate new visual ideas. Synthetic face generation. Ever seen the website This Person Doesn't Exist? It uses GANs to generate photorealistic human faces of people who don't actually exist. These images are often indistinguishable from real photos. In game development, in video game design, GANs are used to create realistic textures, environments, and maps. This helps speed up the development process while maintaining high visual quality. And finally, medical imaging. GANs can generate realistic medical images like MRI scans or X rays. These synthetic images are used to train AI models when real patient data is limited, helping improve diagnostic accuracy. What makes GANs special? Most AI models learn from data. GANs create data. GANs are not just classifiers or predictors, they are generators. They learn the distribution of the data and generate new samples from that distribution. They don't memorize, they imagine. That's what makes them useful for creativity, augmentation, and simulation. GANs have evolved and now they come in many specialized forms. Deep convolutional GAN, good for image generation. Cycle GAN converts images from one style to another, like turning horses into zebras. Style GAN, which is used for generating high quality human faces. Pix to pix, which translates one type of image into another, like turning a sketch into a photo. Big GAN, powerful GAN trained on large scale data sets. Each has a different structure but uses the same core idea: generator versus discriminator. GANs are turning artists into coders and coders into artists. Generative adversarial networks GANs are reshaping the creative world by giving artists and non artists alike powerful tools to generate original content with minimal effort. Digital art and NFTs. GANs can generate unique and surreal digital works. These are often sold as NFTs, non fungible tokens, allowing creators to monetize AI generated content. You don't need to be a trained painter. Just describe your vision and the model creates it. In fashion designing, in fashion, GANs help generate new clothing patterns, styles, and fabrics textures. So, designers can use GANs to create and explore creative possibilities, which speed up prototyping and even personalized designs based on trends or customer data. In music generation, GAN based tools can compose original music tracks in various styles. They analyze thousands of audio patterns and generate new melodies, harmonies, or even entire songs, useful for background scores, games, and media protection. Used in animation, GANs help in creating realistic animations and filling in between frames in betweening, saving time and animation production. They are also used in style transfer to apply artistic filters to animated scenes. They are also used in content generation for marketing and film. Marketers and filmmakers use GANs to generate realistic visuals, synthetic actors, promotional material, or even simulate scenes before production. This reduces costs and enhances creative flexibility. Let's see some popular tools in GAN that would be useful for artists. Runway ML, user-friendly platform for artists and content creators to use AI without coding. Art Breeder, which allows users to mix and morph images using GANs. Ideal for faces, landscapes, and mood. NVIDIA GAN Paint Studio lets users edit and create images using AI generated strokes. You can literally paint objects like trees or doors with a few clicks. With great power comes very tricky training. There are some challenges and limitations that we need to deal with GAN. Training GANs is not easy. The first problem is mode collapse. The generator makes similar outputs over and over. Instability. The training can get stuck or diverge. Data requirements in GANs need a lot of high quality data. When it comes to ethics, deepfakes rise serious concerns about identity and misinformation. Designing a good GAN takes careful tuning and experience. What about models like GPT or diffusion? Where do GANs fit in? GANs generate data through competition, generator versus discriminator. Other models use different strategies. Diffusion models like DALI 2 or stable diffusion work by reversing noise step by step. Variational autoencoders VAEs reconstruct input with a probabilistic approach. Autoregressive models like GPT predict the next token step by step. GANs are great at image realism, but newer models like diffusion offer more stability and control. You don't need to be a researcher to experiment with GANs. There are some libraries and tools that just need to import and work with them. TensorFlow or PyTorch, which is fully flexible for customizing GANs. NVIDIA style GAN, used for photorealistic face generation. And let's see some tools. Runway ML, no code visual interface for trying pre-built GANs. Google Colab Notebooks, which is easy for a beginner. Many open source GAN projects are plug and play. This is such an amazing tool if you are new to GAN. Hugging Face Spaces. Try GAN demos directly online. This is such an awesome tool if you are totally new to GAN. Many tools are free and open source, which is perfect for students, artists, and curious minds. Just try it. We have barely scratched the surface of AI's creative power. GANs will likely merge with large language models and agents, help in drug discovery, architecture, and personalized design. Power AI video generation and deepfake detection tools will continue rising ethical debates and policy needs. With great realism comes great responsibility. Thanks for joining this journey into GANs. From arts to avatars, GANs are shaping the future of creativity and intelligence. Stay curious and see you in the next one.